You ever walk past a fire alarm panel and wondered what's really going on in there? It's not just a switch connected to a bell, not by a long shot. Today, we're going to pull back the curtain and demystify the absolutely incredible engineering that makes these systems, actually life-saving and truly fail-safe.
So let's just imagine this for a second. One single broken wire, and the alarm stays silent. That right there, that's the core problem, the absolute nightmare scenario every single fire alarm system is designed to prevent. Because when lives are on the line, there's just no room for a single point of failure. So the big question is how they do it. How do they solve this?
Okay, so let's start at the very beginning. At its heart, a fire alarm is, well, it's just a circuit. But man, what a circuit. It has one job, one incredibly vital job: find the fire and tell everybody about it. And it has to work every single time. All right, so every system, no matter how big or small, has these three main parts. You've got the FACP, that's the fire alarm control panel, basically the brains of the whole operation. Then you have your initiating devices. These are the things that actually detect the fire, your smoke detectors, pulse stations. And finally, the notification appliances, the horns, the strobes, the things that get your attention. But here's the thing, the real genius, the secret sauce that makes it all reliable, isn't just the parts themselves, it's how they're all connected. And to really get that, to understand the magic, we have to go right back to the problem of that broken wire. So let's start with the simplest way you could possibly wire a system up, and then let's break it. This first method is called Class B wiring. And honestly, the best way to think about it is like one of those old cheap strings of Christmas lights. You know the ones, right? The power goes out from the panel, through the first detector, then the second, then the third, all in one big line. And just like those holiday lights, if one little piece of that wire breaks, poof, everything after that break is completely dead. Now, the panel's smart enough to know something's wrong. It can't see that little resistor at the end anymore, but all those devices downstream, they're totally offline.
So that's the problem. And here is the brilliant, elegant solution. It's called Class A wiring. Instead of the wire just stopping at the last device, it makes a U-turn and comes all the way back to the panel, creating a complete loop. It's kind of like a circular train track. So now, if there's a break somewhere on the track, no problem. The panel just sends power and data the other way around the loop. Every single device stays connected. It's fantastic.
And get this, the thought that goes into this is just wow. To make sure that, say, a piece of the ceiling falling down doesn't accidentally cut both the outgoing and the return wire at the same time, the fire code actually says you should try to keep them at least 48 inches apart horizontally. It's all about building in that survivability.
Okay, so problem one is solved. The broken wire isn't going to take us down, but that brings up a whole new problem. Imagine you're a firefighter running into a huge, smoky building. The alarm is screaming, but where do you go? How do you find the exact spot where the fire started?
Well, the old way of doing things was with what we call conventional systems. And they basically worked by lumping a bunch of detectors together into one big zone. So the alarm panel would light up and say, "Alarm, third floor, west wing." Which is, okay, better than nothing, I guess. But it's really just the check engine light for a building. It tells you there's a fire somewhere over there, but it doesn't give you a clue as to which room it's in. And that is where modern, addressable systems completely change the game. With these, every single device, every smoke detector, every pulse station has its own unique digital address. It's like a street address for each sensor. So now, when the alarm goes off, the panel doesn't just say third floor. It says smoke detector room 314 west wing. And for firefighters, that kind of precision saves priceless life-saving seconds. I mean, look at the difference here. The jump in technology is huge. A conventional circuit is pretty dumb. It just knows if the current changes. But an addressable circuit, it's a data network. It's sending and receiving digital information. This means devices can report way more than just on or off. They can tell the panel exactly how much smoke they're seeing. They can even send a message saying, "Hey, I'm getting a little dusty over here. I might need a cleaning soon." That feature alone, it's called drift compensation, slashes the number of false alarms. It's a massive improvement. So we're doing great. We can survive a broken wire, and we know exactly where the fire is. But there's still one more ghost in the machine, a final weakness. Even on a super reliable Class A loop, what happens if the two wires, the positive and negative, actually touch each other? That's a short circuit, and a short circuit can bring the whole entire loop down. Yeah, I saw this quote on an old engineering forum, and I just had to include it.
A veteran tech wrote, Style 7, oh, the humanity. And it just perfectly sums up the feeling of working with the absolute top of the line, most complicated, most bulletproof system out there, the one designed to survive this very problem. So this beast of a system is called Class X. It used to be called Style 7. This is the kind of system you'll find where failure is simply not an option. Think hospitals, massive airports, super tall skyscrapers. It's built on a Class A loop, so it's already protected from a single break. But then it adds a secret weapon, short-circuit isolators. So how do these things work? How do they stop a short from killing the whole system? It's actually genius in its simplicity. It's so cool. Okay, so imagine your loop is running normally, everything's fine, then, bam, 2 wires touch, creating a short. The isolator modules on both sides of that short instantly detect it, and they act like automatic blast doors. They just slam shut, completely cutting off and quarantining that one bad section of the wire. The short is trapped, and the rest of the loop, it just keeps on working, using the other path like nothing ever happened. One localized problem is stopped from becoming a total system failure. Okay, but we have to remember, a modern fire alarm system isn't just a passive detection system anymore. It's not just sitting there waiting for smoke. When things go bad, it becomes the active commander of the building, taking control of other systems to manage the emergency.
And this is why it all matters. The moment an alarm goes off, the panel isn't just blaring horns. It's talking to everything. It's sending the elevators down to a safe floor so no one gets trapped. It's killing the HVAC fans so smoke doesn't get pumped all through the building. It's telling magnetic locks on fire doors to release, letting them swing shut to contain the fire. It's unlocking doors on the escape routes. It literally becomes the building's automated safety coordinator, orchestrating a whole response to protect people.
Which brings us to this final question. When you're walking through a building and everything is quiet, how do you know the alarm is ready to go? Is it silent because it's safe, or is it silent because it's broken? And as we've just seen, the answer isn't just hoping for the best. It's in all these layers of brilliant engineering, the redundant loops, the smart addressable devices, the isolators, all working together behind the scenes, constantly checking, always ready. It's an entire system designed to guarantee that when you need it most, it will not be silent.